Good morning, everyone. Hello, and welcome to today's webinar, Optical LAN FAQ. My name is Chad Hines, Chair of APOLAN's Technology Committee, and I will be your moderator today. Our third panel will in fundamentals of optical LAN, answer questions, and identify the components of an optical LAN setup. Before we begin the presentation, I'd like to cover the agenda and a couple of housekeeping items. Our presentation will begin with a brief explanation of what an optical LAN is and important terminology. We will then introduce our expert panelists, answer a few pre-selected questions, and use the remaining time to answer as many live questions as possible. Audio has been muted today for everyone except our panelists. For submitting your questions, please use the question feature on your screen throughout the presentation. We will do our best to answer as many questions as possible, and the earlier you submit, the better we'll be able to manage our time. Please submit your questions. Please take a moment to review APOLAN's antitrust and no solicitation policy are on your screen now. We will pause briefly for viewing. The presentation slide deck will be emailed to registrants after completion of the webinar and include information about APOLAN's benefits, resources, and contact information. Here is the moderator and panelists. We will give the panelists a brief moment here shortly after our overview to tell you about themselves. We will go over a brief overview here before we start about passive optical LAN. Here we have a brief connectivity overview. You will see we have our core switch connected to our optical line terminal, and then using a passive infrastructure utilizing optical splitters, and then connected to our ONT, which is providing our end Ethernet connections to our devices. You will see between our OLT and our ONT, we have our passive single mode architecture up to 20 kilometers. This can be extended further, changing out optics. Here's a view of our larger optical line terminals. They are chassis-based, fully redundant, up to 256 PON ports, thousands of ONTs, primarily DC powered. You will see now manufacturers coming out with OLTs that plug directly into AC. Typically, those line terminals will actually have an AC to DC converter on the back of them, bringing in that DC powered redundant system. What you're viewing here are different manufacturers. As you can see, these larger models have many connections on them, thousands of Ethernet port capability. The line cards you will see in the center of the two at the bottom and at the bottom of the black one at the top. These are redundant line cards. They have multiple uplink ports. These can be built in lag groups, anywhere from 1 gig uplink interfaces to 10 gig uplink interfaces, and now that goes beyond. Here are some smaller form factor OLT models. Here's that AC and DC power. Typically, these smaller ones just, have a plug on the back of them to plug directly into your power. Inside the box is still doing that conversion. These are made primarily for the smaller offices. 2 to 32 PON port connections. These are really getting smaller every day. Hundreds of ONTs. These are great for those smaller facilities, bringing costs down to not have to buy that larger form factor OLT when you're not going to need that many connections. These smaller 1RU chassis are great. Now, when we mention optical splitters, a lot of people get confused with this. Splitters provide optical. Oh, I lost my picture there. Splitters provide optical connections in pairs. There's a picture that's not showing up here, but essentially we're taking a single strand of single mode fiber, and then it's being fused to 2 other strands, and then 2 other, and then 2 other, and that's how we are getting our different splitter form factor here, up to 32, and now that's up to 64, and then now it's up to 128. They're splitting a single strand of single mode fiber. Each to split equates to half of the optical power, which is 3 dBs of loss. When we say 3 dBs of loss, this is something that is required within the passive optical network system. Out of the OLT, the lasers are are coming out at a plus 4, I believe, and we're needing to degrade that in order for our ONTs, which are needing to read between a -8 and a -28. Splitters range from 1/2 up to 1/64s. 1/32 is your most common split ratio. Here you see some different splitter form factors, their max loss, typical loss, what their wavelength range is. You'll see it starts out by a 1/2 followed by a 2/2. This is actually a second input for redundancy, or you could be injecting a second wavelength into your infrastructure. You'll see down at the 1/32, it has a max loss of 16.7 dB. That's really the sweet spot for our ONTs to come online. Then you'll also see at the very bottom, we have a 1/2 plus a 1/16. This is if you were going to essentially stack them. We could go from a 1/2 optical splitter, and then out of that optical splitter, connect a 1/16 on each of those legs, and then have our horizontal infrastructure to our ONTs. Here's a picture of some optical splitters. So you'll see they come in many different form factors. We have the cassette down at the bottom left, which plugs into your typical fiber housing, followed by essentially another cassette. You can see the first one, the connections are on the front of it. This other one, it tails out of the front of it. This would eliminate having to purchase additional fiber patch cords. You would have your optical splitter in one fiber housing, and then in an additional fiber housing, you would have your horizontal infrastructure that's cabled out to your station. Then you would patch between those, the optical splitter, and then you would patch into your other panel that has your station runs. Now, if you had this cassette form factor that tails out the front, it might eliminate that patch cable, and you could just connect it straight into your panel. And then you'll see at the bottom right, we have a rack mounted fiber housing. We're starting to see a lot more of these come in. Matches what you like to see typically, 1RU form factor, and you just plug and play from there. Here are our ONTs, optical network terminals. A large variety of ONTs are available. They are AC and DC powered options, desk mount, in-wall, rack mount. Some of the manufacturers do provide battery backups for the units. The ONT will actually mount onto a bracket, and then there'll be a space on that bracket for a battery backup unit. Match interface to user needs, Ethernet ports with power over Ethernet. They come with POTS ports, coaxial for television, and some of them actually have built-in Wi-Fi now. Here's some examples of those in-wall units. They would install into your typical single gang box. Your in-wall units, they look to have DC powered, just because within that single gang box, you're probably not going to have an AC outlet buried in there. So you would have that remotely powered to a DC plant. In the middle, you have your rack mounted versions. These come in different form factors, different port configurations as well. These are going to be more high density and offer a lot more power over Ethernet capability. Then on the right, you have your industrial and outside optical network terminals. Starting with that first one, which is actually an SFP. The SFP is an ONT. You could plug this into any device that takes in an SFP, and then we could actually manage that from the management system. To the right of that is an outdoor ONT. This is meant to be on the outside of houses, a building. The ONT is actually inside the box, and then from there you would copper cable inside the facility. Underneath that, this one is a really neat one. This is a hard ONT meant to be in harsh conditions. They designed this one initially for a stadium underneath the stadium seats. They were deploying Wi-Fi throughout the stadium, and it was getting really hot in the enclosures. So that manufacturer actually designed this ONT specifically for that, and now it's used all over. So one thing that's really great about this is manufacturers will definitely work with you to develop solutions to meet your individual needs. Now, this is a really neat slide. It gives you a great comparison between our traditional LAN versus our POL system. On the left, you'll see we have our legacy copper-based LAN, followed by our passive optical LAN. You see a lot more equipment in our traditional LAN environment. We still have our core router up there at the top. Then we have our campus aggregation, followed by building aggregation. And then we have our backbone feeders feeding all our intermediate closets and then patched into our end devices. Now with that legacy base LAN, we have a limitation, right? That limitation is the copper cable. We're held to that 300-foot distance, which is having us build additional IT closets. If we have a large facility, we got to start building more IT closets because we can only go that 316 feet with this copper cable, and that includes that patch cable. So now we're having to run fiber, build additional closets, add all these layer 2 workgroup switches in order to accommodate for our end users. Now with our optical LAN system, we still have our core router. That's how we're getting outside. We're uplinking that to our optical line terminal. And remember, from our optical line terminal to our ONT, we can go up to 20 kilometers. It's roughly 12 miles. What's allowing that is we're required that signal loss in between the OLT and the ONT in order for it to range and come online. So that's why we're putting in our optical splitters, which are essentially replacing all those workgroup switches, because your workgroup switches are giving you your Ethernet connections. In this case, we have a passive infrastructure, and we're locating our optical splitters either in an enclosure on the wall, could be in a ceiling tile in an enclosed accessible box in the ceiling grid. There's no power required for these units. And then from there, we're distributing out to our ONTs. So our only active components within this are our core router, our line terminal, and our ONT, which is typically at the desk. Now, if we're feeding, we get asked questions about the wireless and security cameras. Those ONTs could be installed in a ceiling enclosure and then patched in from there. So this slide gives you a really great comparison between the two. Now here's the architecture of our POL network. We have our core router, which is then patched into our optical line terminal. And as I mentioned, those two center cards, those are our uplink interfaces. We could build this in a lag. They are redundant. They're hot swappable. It's a chassis-based system. One thing to remember is this is carrier-grade equipment as well. Now, from that OLT, we have our single mode, single strand fiber going out to our optical splitter. And then from that optical splitter, we're feeding a single strand, single mode fiber out to our ONTs. Now we are transmitting and receiving on the same piece of glass. This is simplex, it's not duplex. We are feeding downstream at 1490 and then upstream at 1310. These are different wavelengths that we're able to communicate and send traffic. That's how we're able to use a single strand of glass. Now, as I mentioned, everything in between the OLT and the ONT is all a passive infrastructure. There is no power required for this. It's all single mode fiber. Now, when we introduce, as I mentioned, those ONTs come in different form factors, different configurations. Some of them have that RF video port, that coaxial port. Now, when we introduce the RF video, we're inserting a WDM coming from an EDFA that sends traffic down at 1550 in the downstream direction only. This is only sending traffic down to your TV. That TV doesn't communicate back upstream. So that's how we're getting our RF video, as we introduce it with a WDM. Now, when we get into 10G PON, we're introducing additional wavelengths. Those wavelengths could be coming from a separate line card on the OLT. You could have a multi-gig port on the OLT. This is where that 2x2 splitter could also come into configuration. We could inject those 10G wavelengths into that second port on the optical splitter. You'll see we're sending downstream at 1577 and upstream at 1270. What's great about this is you only have to upgrade users that actually are needing that 10G PON. We're using the same infrastructure, the same optical splitter. We're not changing out any hardware except the ONT to a 10G PON. So you could have one office still streaming your typical GPON, and then the office next door using 10G just by switching out the ONT and having the proper configuration on the line terminal. Now, when we look at power considerations for your ONTs, we get asked this a lot. Where's our PoE? How do we power our ONTs? What's remote powered? There's several ways to deploy your ONTs: rack mount, wall placements, drop-down ceiling boxes, SOHOs. ONT placement is really defined by the best powering options. Does the ideal location have nearby electrical power? Is it available? Is the application or service requiring backup battery? Is power conversion AC to DC required for the device? If PoE is required, is the location within maximum distance from the switch? Typically, most the ONTs you purchase these days are all going to have PoE capability. But how much PoE is required at the ONT? That's the question. The cost to add additional AC electrical outlets, could be significant. This might lead you into a remote power situation. Does a local or remote power solution better fit the project? There's definitely different situations, different needs, different customer needs. What's better going to define the situation? You'll see we have a picture of a locally powered ONT. This is an older model. They've definitely changed out that ONT. They have gotten smaller. And then you'll see a ceiling enclosure that has an ONT mounted in it. From here, you would have your copper connections out to your devices. Those in the ceiling enclosures are typically going to be remotely powered. Now, here's some powering options for our local powered. We have our power brick, which is then patched into our ONT. The power brick is really doing the conversion for us. Whenever you see your power cords for your devices and you see that brick on that cable, that's what that's doing. It's actually converting that AC power. We could also have local universal power. And then we have our AC, our remote DC power conversion down at the bottom, where we have a large rectifier system. And then patched into that rectifier system, we have a DC to DC power distribution unit, which is then cabled with a 2-conductor wire out to our ONTs. When we look at doing remote power, keep in mind now we're introducing a limitation to our network in terms of distance. We are held to distance limitations when we look at doing remote power due to voltage drop, the draw from that ONT. So keep that in mind when you look at doing remote power systems. Now, the migration to 10G and NG-PON, what did this look like? So the cabling infrastructure stayed the same, only upgraded users that needed it. You'll see we had our standard GPON wavelengths and then our video overlay, and then we have our NG-PON 1 and our upstream and down waves. Now the migration to 40, which is NG-PON 2, we still have all our same wavelengths. Cabling infrastructure stayed the same. We're just adding additional wavelengths. So we're coming into pairs between 1525, 1544 for our upstream, and then we have our downstream lengths at 1596 and 1603. Then we have our point-to-point, which is using additional 2 pairs between 1603 and 1625. Here are our standards down here at the bottom. You will see for our GPON and GPON 1 and NG-PON 2. GPON, I don't think I did mention, is 2.5 down and 1.25 upstream. And then NG-PON 2 actually had 2 versions, XG-PON and XGS. You'll see the difference there. XG was 10 down and only 2.5 upstream. And then XGS is 10 up, 10 down. Followed by NG-PON 2, 40 down and 40 up. Now here are our panelists today. We are missing one panelist, Magnus. We will go ahead and let the panelists introduce themselves. Lonnie, please, if you could introduce yourself first, followed by Matt.
Sure. Hello, everyone. My name is Lonnie Barrington. I work for a company called DZS, and we manufacture and sell some of the OLT and ONT equipment you've seen in the preface here. I've been involved with passive optical LAN since 2011. That's kind of the early birth time, and I've worked with a lot of people and look forward to pushing this out to more and more people as they learn about the benefits of a passive optical LAN network.
And my name is Matt Miller. I work for AECOM. We're an integration firm, so we're the ones that make all this stuff work when you try to plug it all together. I've been doing this for just about the same amount of time as Lonnie, maybe a year or two longer, but have lots of experience working in various vertical markets, and I look forward to answering any questions you might have. So type them in.
Great, thank you, everyone. And as I mentioned, Magnus was unable to attend. So we're going to get into our FAQ. Please, questions. We have a few preloaded questions here that we get asked a lot. We're going to go ahead and go through these first, and then we will answer your live questions. Please send those in. We will start off with our first question. If one of you two could please jump in.
My Wi-Fi.
Okay, great. Would you like me to read it for you?
Yeah, go ahead.
Okay. My Wi-Fi access points offer very fast throughputs and have 2.5 gig interfaces. Can optical LAN provide these speeds?
And the easy answer is yes. Many of the manufacturers offer not only 2.5, but 10 gig multi-rate Ethernet interfaces on their ONTs today. Generally, you would want to use a XGS PON 10 gig system to offer those ONTs. Although some people have made, because GPON is a 2.5 gig or close to it down speed interface, you can run a 2.5 gig Ethernet off of a GPON ONT as well, but they're more limited. You're going to see it more often on a 10 gig or XGS PON kind of system.
Great, thank you, Lonnie. Let's see, I've heard that passive optical LAN has shared bandwidth. Is that a problem?
I'm certainly glad to take this one since Lonnie answered the last one. So the answer is yes, passive optical LAN does have shared bandwidth, right? The PON port that feeds the signal to the splitter, as you talked about, Chad, that has either a 2.5 gig down, 1.25 gig up, or maybe 10 gig symmetrical bandwidth typically served out of it. And that is shared between any ONTs that are connected to that same splitter. But this is not much different than what we see in our traditional, excuse me, our traditional networks. If we look at our traditional model, we usually have maybe a 10 gig feed, excuse me, a 10 gig feed to a closet, and then 1 gig feeds off of the 48 or 96 ports that are fed by that 10 gig. So it's not a problem. In fact, it very much mirrors the type of bandwidth you're going to get through a traditional system. It just looks very different than what we have today. So sometimes that scares people.
Thank you, Matt. Can optical LAN offer PoE, power over Ethernet? I think I answered this partially. If one of you would like to jump in addition and add anything.
Absolutely. You've already covered that the ONTs can provide PoE to the endpoints, and most of the requirements for PoE range from Wi-Fi access points to security cameras to door locks. There's many applications where you would require PoE, and then there's also many levels of PoE, which all vendors try to adhere to. The latest being PoE++, which is a 60-watt PoE that are available on almost all ONTs that offer PoE these days. So yeah, and it'll supply that 48 volt, just like a PoE closet switch would.
Yeah, thank you for that additional input. Is optical LAN included in any global standards?
I better get that one since Lonnie gave us the lowdown on the PoE side. Yeah, there's many standards that that are encompassed by optical LAN. So depending on what aspect of it we're talking about, we have different different standards that apply. So the GPON and XGS-PON standards, the communication between equipment, that is handled by the ITU through the G.985, 986 standards. And then we also have the standards around cabling and installation. So the TIA 568C standard started addressing optical LAN with the C version, and we've seen that progress since then. And we've also seen the BIC-C TDMM installation manual address it as well. So I think starting with version 14, if I recall correctly, the TDMM also covers the installation of this equipment. So really from the inception and the cabling and the installation all the way through the electronics and how they intercommunicate, those are all governed by global standards.
I think it's good to add that even though those are some of the PON standards and the building infrastructure standards, there's a lot of Ethernet involved, even though this is a passive optical. So all your 802, IEEE 802s are supported, .q, .p, in that effect, .1x. So there are a lot of Ethernet standards that we uphold as well.
Yeah, that's a good point, Lonnie. Thanks for bringing that up, because yeah, we often get those questions from folks when they're evaluating the technology. Does it support VLANs and things like that? And yeah, then we're referring to all those 802.x standards, just like you talked about. So good point.
Yes.
Yeah, thank you both. That was a good little discussion there. We're going to go ahead and move on to the live Q&A. Please send in your questions for those of you who have already. Thank you. We're going to go ahead and jump right into it. Lonnie, we're going to send this one to you.
Sure.
Can I provide tagged and untagged services on the same ONT port?
Yeah, so that's a good question people ask, because a switch, when you're configuring a switch, you may do, in some big company's name terminology, it would be access and trunk. And for reasons like a Wi-Fi access point needs an access untagged for its management, but then it also needs tagged VLANs 802.1q for all the Wi-Fi radios it's sending out. There may be several SSIDs and they may be segmented by different VLANs. So yes, we can simultaneously send an untagged out the port along with tagged interfaces. Another common usage of that is an IP phone. So an IP phone would plug into the ONT, and then it adds another factor, which is LLDP, another standard that comes into play. Link layer discovery protocol. The phone will ask the ONT, hey, what VLAN do I use for voice? And it will then put the voice VLAN into a tagged member of that port automatically and send it to the phone, which will register on that tag VLAN, but also send that untagged VLAN out of the back of the phone so you could plug a PC. For a typical desktop workstation, you may have the PC and the phone connected in series there.
Yeah, great. Thank you, Lonnie. Matt, we're gonna send this one to you here. What markets are using optical LAN? I think this is a good question here. We get asked this for new incoming customers, if it's been done with us before, who has done it, for those worrisome customers.
Yeah, we do hear that question a lot. Folks are, like you said, they're worried about maybe being the first ones or doing some technology that they haven't seen before. The answer is if you don't know of a peer that's doing it, there is one out there. There's lots of them out there in your industry. There's certainly some industries that have picked it up more strongly than others. Hospitality is one that has grasped onto this technology and really run with it. So we see all the major flags using this technology, either putting it into their standards, their brand standards, or even recommending it as the preferred technology in their hotels. And so, yeah, we've done a number of installs in the hotel world with the technology. The developers see the value because it's a less expensive technology to put in. Plus, they're not going back in 5 or 10 years and ripping out cabling, opening walls, and things like that. So it's an easy proposition for those folks. Other big industries where we see it taking hold are education, both in higher ed and in K-12. Higher ed is an obvious fit because of the long distances that are covered. This technology, I don't remember if you covered it, Chad, but this technology has a heritage in the telecommunications world of, fiber to the home, fiber to the business. And so education, especially large campuses, are that model, right? They're long distances and they're covering the triple play services, the voice, data, video, maybe a little bit less of the voice these days, I guess. But either way, they're covering all those technologies much in the same way a city would, or a carrier would to a city. So we see a lot of uptick there. But like I said, pretty much every industry we're seeing it. Government is big. We see a lot of corporate applications for it, simply for the money savings. Retail, you name it. Pretty much every application I think has been covered at this point.
Yeah, great. That was great background, Matt. This question probably came in. I'm not sure whichever one of you two want to take it. You probably both have some input on it. I mentioned layer 2. That's why I think this came up now. Does any of the hardware offer any layer 3 routing? And if not, is there any future for that?
Yeah, I can answer that. So the quick answer is yes, it does. A lot of the ONTs can provide layer 3 routing, but that's usually used more often in a residential or fiber to the home kind of deployment, where you want to give one IP address to a house or maybe an apartment and then have a subnet behind it, which is probably private. Just like your home internet router would be today, you might have a 192.168 something. And it can do the routing at the ONT. Typically, there's not a lot of routing on the OLT because it's a really big switch and it just wants to push packets as fast as possible with minimal latency. I don't know, Matt, you think, is there other routing solutions out there?
Yeah, I mean, I hear the question a lot about the routing on the head end side, right?
Yeah.
Upstream from the OLT or at the OLT. And we get the question, but I agree with you. We don't often see the need for it there, right? Those are typically separate functions. We've seen the traditional manufacturers, for traditional copper systems kind of mash those together. But I like to think of the OLT and ONTs replacing the distribution and access layer and leaving all the core routing to a dedicated device, like you said, a device that's specifically made to do that. It'll do it better and it'll do it efficiently and it'll do it in the right place. We don't need the OLT to do that.
I agree.
Yeah, great. Thank you both. Lonnie, since you chimed into it a little bit there for a second, I'm not sure if you have anything else to add to it, but just because the question came in, how is Optical LAN different from fiber to the home technologies?
Sure. That what I just said, the routing involved. Now, sometimes you may just have a straight layer 2 to a home and let the home put their own router. So they would provide a router behind that endpoint. In that case, it would be very similar. One of the other things is when you're doing a fiber to the home deployment, you really don't want those homes talking to each other. You don't want your neighbors hacking into your network. So we and other vendors implement a lot of port protection. So we protect one port from talking to the other. Where in an optical LAN, you want to talk to the other ports, right? You may have file sharing, you may have printers on the network, you may have local servers embedded, and you do need to have what we call a transparent LAN service instead of a normal up and downstream kind of serving subscribers at an endpoint. So I think those would be the major things. Also, in homes, you may have Wi-Fi interfaces. We discussed that a little bit on the overview, that some ONTs have Wi-Fi built in. You're probably going to see that a lot more in a fiber to the home deployment with this same equipment than you would on an optical LAN. You know, you're not going to want to have a Wi-Fi access point that close to 29 others, right? So the Wi-Fi, you're probably going to have one central Wi-Fi device plugged into a PoE ONT, but not every ONT. So I would think that's something that causes a difference.
Yeah, and I think
Great.
people might not even realize that a lot of the hardware is quite similar between equipment, right? Like the OLT that you put in for your LAN might very well be the same thing that a carrier uses in their central office. But as Lonnie was saying, maybe you pick different ONTs, right? Because you don't want that Wi-Fi access point built into every single ONT.
Yeah, and then there's, when you do add in the optical LAN side, there's a few technologies that you wouldn't use in a home, like LLDP and 802.1x for security. So there are some special things that you have to think about when you're deploying to a enterprise or an office that you wouldn't have to worry about if you were just sending to someone's home.
Yeah, great discussion. Matt, we could put this one to you. What speeds can I deliver with optical LAN?
Oh man, the sky's the limit. You know, it's we had that question about shared bandwidth earlier, right? And I think that kind of preempts maybe the question that we got here about this, right? But we saw this the standards that you addressed, right? That GPON doing 2.5 gig, XGS-PON doing 10 gig, NG-PON2 doing 40 gig, right? There's also applications that are doing 25 gig and multiple wavelengths at 25 gig. So the standards allow us to go quite high in terms of the amount of bandwidth that we can deliver to the endpoint. So sometimes people get wrapped up about shared bandwidth, but I would offer to them to look at the overall picture here, in that we can offer such a vast amount of bandwidth, whether you share it among one ONT or 32, that's up to you, right? You can engineer the system to do what you need it to do. A number of manufacturers also offer point-to-point systems where you can mix and match, so that maybe one endpoint is on an XGS-PON port with a splitter and shared amongst several ONTs, but the ONT next to it is actually patched directly back to the OLT, and it has a dedicated 10 gig pipe or greater right back to the OLT. The nice thing about that is you're using single mode fiber, which, you know, has at this point undiscovered bandwidth limits, right? We don't know what those limits are at this point. So you're covered for the future. And as far as capabilities today, you can deliver as much bandwidth as you need over that fiber.
Yeah, that's important with what you said about undiscovered. You know, at one point, I think they had tested 69 terabits or something over single mode fiber. So once you install that fiber in your infrastructure, you don't have to go back and change it every few years. You can come around and change the endpoints, right? And maybe change the optical card. And there's definitely on the horizon, there's 50 gig and 100 gig PON. So it's great to have, even if you just deploy the fiber and get it in there, that's a good investment for the future.
Yeah, I know everybody on this call has been through that life cycle or is aware of how disruptive that is, right? To tear out your Cat 5 to go to 5E or 6 or 6A or whatever the standard du jour is that gets you the bandwidth that you need. So that cannot be understated, just how future-proof this single mode fiber is, right?
Yeah, you kind of hit the topic of this next question, Matt. If you want to take it, Lonnie, you could probably chime in as well. But the question is essentially, can you install passive optical LAN in phases? I think to elaborate on that, do they have to change out their entire infrastructure right away.
Oh, right. Yeah. I mean, yeah, certainly we don't always have the convenience of saying, all right, we're going to tear out the entire network and start from scratch, right? That's never the case unless we're talking about a greenfield application, right? So the answer is yes, you can do it in phases, right? We have seen some customers where they will use rack mount ONTs in closets to serve over existing fiber and feed those those rack mount ONTs via trunk fiber basically to the closet, similar to the traditional model, right? And then as the funding and displacement of people becomes available, then you can start bringing the fiber deeper into the environment, because that's the goal, right? We want to get that single mode fiber out to the end users as deep as we can, and then make that the last upgrade we ever do, right? In terms of opening up walls. So yeah, you can certainly do it in phases. And then as you go beyond that, right, as we talk about going from 2.5 gig to 10 gig to 25 or 40 gig in the next phase, then that upgrade is not ever opening the wall. It's simply replacing the ONT at the desk and maybe patching them into a different OLT if it dictates that. So this would be your last phased upgrade of replacing the fiber, and then from then on, you're just swapping out electronics.
Yeah, thank you, Matt. Lonnie, I think I'm going to send this one to you. Does passive optical LAN support port security? What's the security levels?
So yeah, absolutely. We touched a bit on that earlier with standards, right? We talked about 802.1x, and that's a port security mechanism that allows things to authenticate to an authentication server. And then the ONT will coordinate with that authentication server and either give them access or deny them access, and may put them into a guest network where they can't get anywhere. Sometimes we call that a walled garden or a black hole, where, hey, you plugged in a device that we don't recognize and we don't want on our network today. We can block that, right? And otherwise, maybe you're the VP of sales or something, and you get put into a special VLAN with access to all of your servers or whatever you need to access to. A lot of times in the government, the high-ranking people want to have specific access to top secret stuff, right? So they can get pushed into that. But there's also much simpler port security that you could add, and that is maybe an ACL, block certain MAC addresses. And this, we've seen this a lot with touching on an earlier subject, video, right? Maybe your video, you have a device, a set-top box to control the video, and you plug it in, but you only have one brand and you don't want anybody in your company using something they bought off eBay, right? So they plug that in, we can just block it because the MAC address doesn't align with anything up there. Another one is something you may have heard in the industry called sticky MAC, right? And that's, we intercept the DHCP packet and handshake, and if they get a successful handshake, we lock down that MAC to that port and say, yes, you're allowed to talk, right? If somebody tries to come in and spoof without doing a DHCP handshake, we're going to block them. We're not going to let them come onto the network. So there's many levels of port security you can have there.
Yeah, and I might add on to that just the inherent security of the technology itself, right? Beyond the port, fiber itself, right? We know the government loves fiber rather than copper because fiber doesn't emanate that signal. It doesn't have RF signal interference where it's basically blasting the signal out into the air. And also the built-in encryption. I don't think we touched on that, but the standard allows for encryption either in one direction or both directions between the OLT and ONT built into the system. So another layer of security for those for all those security guys that are examining your system before it gets installed.
Yeah, if there's some way they could tap into the fiber and break down the signal, they're not going, it's going to be encrypted and they can't do anything with it.
Exactly.
Yeah, great. Thank you. Thank you both. Matt, we'll send this one to you. Does optical LAN only operate on single mode fiber? I feel we get this question a lot with new customers.
Good question. It is specifically designed for single mode fiber. That is the application. We have actually seen certain manufacturers provide adapters that will change the modulation so that the signal can actually travel over existing multi-mode fiber. So it's a very specific application, and it does have certain limitations. So our 20 kilometers, number of connectors and loss change when we do that, but it is possible with certain technologies to put it over certain multi-mode fiber.
Great. And we're going to keep this one with you, Matt. Isn't fiber more delicate than copper?
Yeah, I love that one. Everyone's always worried about their fiber, and I'm gonna break it if I bend it too far, and be very careful with it, and waterfalls and all those types of things to protect the fiber. It's not more delicate than copper. It's far more robust than copper. If you haven't dealt with fiber in many years, I don't fault you for thinking that it might be delicate, but virtually all fiber that's manufactured today is reduced bend radius. There's another standard for that, the G.657, I believe it is, standard, talks about the bend radius of fiber. And so you can get fiber that goes down to 5 millimeter bend radius. So if you think about that, that little tiny wrap it around a pencil, basically, type of diameter, wrapping that cable around with no noticeable attenuation, no noticeable loss of signal over that fiber at that bend radius. You're not going to get that with copper. I don't remember what the copper is these days, but it's funny because copper keeps going up with bend radius and fiber keeps going down. So I want to say copper is somewhere in the 30 millimeter bend radius range, whereas fiber is now in the 5 millimeter range. So the tables have turned, copper. We gotcha.
Yeah, great. Thank you. We got a few more minutes here. We'll see if we can get a couple more of your questions. Lonnie, I'm going to give you this one. Can we go past that 20 kilometer distance?
Yeah, absolutely. And becomes a bit of a math thing, right? So to get further than 20 kilometers, there's a couple of things that come into play. You got to have more power. So one, you replace the optics, and there's a few standards for optics. The normal one is on GPON is a B+, and then we move to a C+, which gives it about 4 more dB of light to start with, right? And it has a better lower receive sensitivity to pick up lower light. So now you have that, and that'll shoot out to about 60 kilometers. But there's one important thing that you still got to remember, and that is timing, because when these ONTs are talking back through that splitter, they kind of have to take turns, and they share. There's all kind of dynamic bandwidth allocation where we take turns, and it takes so long for the light to travel from the ONT back that there's a specific window you have to adhere to, and that is 20 kilometers. At 20 kilometers, there's no adjustment to the signal. If we send it, you're going to get it and repopulate it. You're not going to drift outside of your window. So if you went 60 kilometers, the closest you could be to the OLT would be minus 20, 40 kilometers. So you can go from 40 to 60, or you could back up and go to 20 to 40, or 0 to 20 as the normal standard is. So those are the things you have to think about if you want to go. I don't think I've encountered an optical LAN that needed that kind of extended distance, but maybe a very large campus or multiple campus sites within 20 miles. That's pretty far. You'd probably want a new OLT somewhere instead.
Yeah, great. Thank you, Lonnie. We're going to get one more question here, Matt. We're going to give you this one. Why aren't more people using optical LAN today?
Oh man. Yeah, I mentioned, right, you might not know a peer that's using it, but they're out there. It takes somebody with an open mind, somebody that is willing to expand their horizons and look at something new, right? It's not what we're all used to. It is different. And so if you're willing to take a jump and try something new, you can definitely be rewarded by using this technology, right? It can save you money. It can make your life a lot easier by installing it. So, but you got to be willing to take that risk of something different. But talk to us. We're glad to help you out along that journey.
Yeah, great. Thank you. So about APOLAN, just to do a little closing here. We are out of time for questions. Thank you again, Matt and Lonnie, for sharing your time and expertise. We encourage all of you to review APOLAN's association information on the next slide when you receive a copy of the presentation and the evaluation survey email. APOLAN advocates the education and global adoption of optical networks for the local area network marketplace, shaping the optical LAN industry, lead the evolutionary technology, promoting optical LAN with education, white papers, case studies, and published articles. On behalf of everyone at APOLAN, thank you for joining us today. We look forward to seeing you again soon on another APOLAN webinar.